Hello, class. So we are in section 10.4 now, and 10.4 is about the algebra of matrices. Okay, so we're going to do algebra with the matrices this time, not just use them to solve things, okay? So first, if we have matrices, all right, if we have a matrix A and matrix B, when are they equal? Right? That's like a pretty obvious question, but it's actually a little confusing, right? Like, are these equal to, all right, or are these equal, right? The answer is no for both, all right? Um, so we have to think about it though, because it's not as simple as numbers. Numbers are equal when they're like the same, right? But here we have like entries and dimensions and all of these other things, okay? So A and B are equal when one, they have the same dimension. Okay, so you need the same dimension matrix. So that's why these aren't equal, because they're different dimensions, right? This one is a 2 by 3, this one is a 2 by 2. And then number 2, every element is equal to its corresponding element. All right, so that means like right here, 1 is equal to 1, 2 is equal to 2, 3 is equal to 3, but 4 is not equal to 5, okay? So you need all of them to match to be equal, okay? All right, so that's when you know they're equal. So then now, we need to think about how do we do the other things, like add and subtract. All right, so first rule of adding and subtracting is you must have the same dimensions. Okay, so for example, I can't add things that are different. Okay, so like, okay, these, all right, does not exist. Okay, so you can't add anything or subtract anything with different dimensions. All right, step one, they have to have the same dimension. Okay, and so two, after you have the same dimension, then you can add and subtract, and this is how you do it. Okay, so you add and subtract element by element. So what do I mean? Okay, so first off, you crack open your textbook or read any stuff on this, you'll see usually this is what they call the elements in general. Okay, and then just to like explain it, I, J. Okay, the first number is the row, the second number is the column. Okay, so this is why it's A11 because it's in row 1, column 1. This is why it's A12 because it's in row 1, column 2. Okay, all right. So if I want to add two matrices, all right, what you do is the answer is going to still be a 2 by 2, and you just add the corresponding elements. So A11 plus B11, A21 plus B21, A12 plus B12, and A22 plus B22. Okay. All right, so just quick examples. So here I have a 2 by 1. Okay, and we're just going to add them. So 1 plus 4 and 2 plus negative 1. Okay, 5, 1. Ta-da! Okay. Another example. 2, 0, 0, 1, 4, negative 1, plus 1, 0, negative 1, negative 1, 0, 1. Okay, so they have the same dimensions, right? These are 2 by 3s. These were 2 by 1s. Okay. Let's add them. Okay, so I'm going to do 2 plus 1 is 3. This is going to be 0. This is going to be negative 1. 1 plus negative 1, actually 0. 4, also 0. Ta-da! Answer. All right, now, if I have a subtraction, right, if I'm subtracting matrices, okay, then I actually have to subtract all of the elements. So what it looks like is it's going to be 2 minus 1, okay, where this minus is this minus. All right, 2 minus 2, 1, 1, okay, minus minus, negative 2, negative 4. All right, so we're gonna get 1, 0, 3, and 5. Okay, ta-da! Subtraction. Okay, so adding and subtraction, not too difficult. Now moving on to something else. Okay, so this new thing is going to be called scalar multiplication. Okay, so what is scalar multiplication? So first of all, I'm just gonna do the example. Okay, so here's an example of scalar multiplication. All right, why is it called scalar multiplication? Because this thing is called a matrix, right? But this, the number, right? The number math people like to call a scalar, okay? So scalar kind of just means number, not, right, nothing special. So what you do is kind of like extreme distributive property. Scalar multiplication is just you multiply the scalar to all elements in the matrix, okay? So it's going to be 3, negative 6, 27, 0. Okay, this is scalar multiplication. And technically, that's sort of what I did here. I technically scalar multiplied the negative 1 and then just added in a weird way. But let's see this happen. Okay, so now notice the scalar can be a fraction. Okay, so that's possible. Okay, so if I have a scalar, I multiply it to every single element. Let me make one of these odd. Let me just 5. Okay, so what happens, basically I divide everything by 2, right? So I'll get 1, 2, negative 3, 4, 5, negative 1, negative 2, 5 divided by 2, and 3. All right, and that's the answer. Okay, and get used to fractions. All right, this entire section has a decent amount of fractions that are unavoidable. All right, but also, okay, we can do scalar multiplication kind of backwards, or we can do like scalar factoring. Okay, so what I mean here is notice everything here is even, so I can pull out the 2 and get this matrix. Okay, that's also totally fine. Okay, so this is scalar multiplication. All right, and then now technically I can give you like algebra problems, or you can do like chapter 1 stuff with it. Okay, so for example, if A is 1, 0, 2, negative 3, and B is negative 1, 1, 0, 1. Okay, I could ask you to solve for x where you get this, this equation. Okay, so here I have like an equation, right? It's just notice that A isn't just a variable, A is this matrix, okay? But you solve it just the same, okay? So I'm gonna subtract A to both sides and get negative B minus 3A. And then I'm gonna divide by 2. And ta-da, there's the answer, okay? Now you just need to actually, tell me it explicitly, okay? So, negative B is going to be 1, negative 1, negative 1, 0. Minus, I'm going to put the 3 inside. So minus 3, 0, 6, negative 9 divided by 2. This is going to be, I'm going to put the 1/2 in front. Negative 2, 0. Negative 7, 8. Ta-da! Answer. Okay? So you can do pretty much everything you know already if I just label them A and B, right? So that's nice. All right, so you should know how to do most algebra with matrices now. Okay, the only problem is where I taught you this thing called scalar multiplication. What about multiplication? Okay, and that's kind of where we get a problem. Okay, so regular multiplication is a little bit annoying with matrices. Okay, so the first thing is I need a warning. Okay, the multiplication for matrices is not commutative. Okay, this is a huge warning sign. Okay, not commutative. So if you remember, what does that mean? That means AB does not have to equal BA. Okay, so if you just swap the order of stuff, all right, it might not be equal anymore. Okay, so the order matters. All right, now let's do matrix multiplication. Okay, so matrix multiplication sometimes has fancier names called inner product or a dot product. Let's not worry about that. Let's start off very simple. Okay, so let's have this matrix. Okay, so first of all, what you have to do is you have to check, are you allowed to multiply the matrices? Okay, and what I do is I always write down their dimensions, right? So this is a 1/2 and this is a 2/1. Okay, so to check if you're allowed to multiply, you look at the middle two and you check if they match. Okay, they need to match. If they don't match, then the answer does not exist because you're not allowed to multiply them together. Okay, so they need to match. And also, okay, the leftovers, these two, okay, that actually tells you what your answer is going to be. Okay, so when I multiply these two matrices, I'm going to get a 1/1. All right, which is, a little funny. Okay, but how do you do it? Okay, you're going to multiply the saying that we all say is you do row by column. Okay, row by column. That is how we do matrix multiplication. So here I have a row, and I'm going to multiply with this column. Okay, how does that work? I'm going to take this 1 and multiply it with this -1. Okay, so 1 times -1. Then I'm going to put a plus sign, and I'm going to multiply this 2 by this 3. And then I would keep going if I had more numbers, but I don't. So I'm done. Okay, so the answer is this thing. I just need to figure out what that is now, right? So this is -1 plus 6, so 5. Ta-da! Okay, so that's the hopefully simple example. Okay, now kind of to show you how weird stuff gets. All right, let's do this other, what you would think maybe is probably the same level of question. Okay, let's do -1, 3 times 1, 2, right? So here I'm literally just swapping the order, if you noticed, right? Now though, check, right? What is this? This is a 2 by 1. This is a 1 by 2. So these match, which is good. But look, that's a 2 by 2. So the answer actually is going to be a 2 by 2. All right. And now I'm going to, because remember, okay, so now I'm going to go row by column. So this row, I'm going to multiply with this column. And that's going to give me -1. Then I'm going to take this row and multiply it by this column. That gets me -2. And you see why now I have 4 entries, right? Row 2 times row 1, 3, row 2 times this 6. Okay. All right. And we see that, like, right, they're obviously not equal, right? They're not even close to equal, right? They have different dimensions. So proof that the commutative property does not work anymore, okay? You have to be careful that you never swap the order, okay? Unless you're doing it intentionally for some reason, all right? Okay. So now let me make a slightly harder example, okay? So 1, 2, 3, 0, 1, -2, 1, 3, 1. Okay. So right, this is a 1 by 3. This is a 3 by 2. So my answer is going to be a 1 by 2. Okay, and let's see what it is. Okay, so actually, this is going to take some space. Okay, so remember, row by column. So row by column. So I'm going to get 1 times 0 plus 2 times 1 plus 3 times -2. Okay, and this is going to be the first entry. Okay. Then same thing, but now row 2. So I'm going to get 1 times 1 plus 2 times 3 plus 3 times 1. Okay, and that's the second entry. All right, so then you just figure that out. So 0 plus 2 minus 6, so -4. And then 1 plus 6 plus 3, that is 10. So ta-da! And you see that the answer is a 1 by 2. All right, one last kind of example. So A equals 1, 2, just kidding. 1, 3, -1, 0. B equals -1, 5, 2, 0, 4, 7. Okay. AB equals, and let's figure this out. Okay. So row by column. -1 plus 0. Okay. Row by column. That's going to get me 5 plus 12. Okay. Row 1, column 3. 2 plus 21. All right. Do it all over again. This is 1. This is going to be 5. No, -5. Just kidding. This one's going to be -2. Okay, so figuring that out, you're going to get -1, 17, 23, 1, -5, -2. Ta-da! Okay. All right, now I'm going to do the opposite, right? So I'm going to figure out what's b times a. Okay, so remember, now it's b times a. So I'm going to do row 1 times column 1. Okay, so -1, -1 times 1. Okay, plus 5 times -1 plus 2 times nothing, right? So if you check the dimensions, right, this is a b is a 2 by 3 and a is a 2 by 2, right? So they don't match. So the answers does not exist, actually. Okay, and it should be hopefully obvious that even if you forget to do the matching thing here, right, you'll just run out of numbers. Like they won't match properly, right? Like here, when I was doing row by column, there isn't a third number to, do something with the 2 with, right? So hopefully it self-checks itself. And also now you see again that commutative property is dead, right? Like here we got this, here it literally doesn't exist. Okay. All right. So let me just go over some rules. More rules. So the associative property, okay, still works. So you can put parentheses places, right? You can choose what order you actually multiply in as long as you're not swapping stuff around. Okay, and then second, the distributive property also still works. Okay, so you're allowed to do this. All right, however, this is left distributive property. We now, because we can't swap orders because the commutative property is broken, we now have a right commutative property, okay? Where it's this, and remember, you can't switch any of the letters places. So the A has to be on the left in the second one, and the A has to be on the right in the third one, okay? And this is the right distributive property. Okay. Now, just to kind of preview why we did this, all right, in the next section, right, remember how I told you that, like, oh, you can do algebra now, right? So you can solve for x. Well, we're going to do that, but what happens this, right? How would you solve this thing for x? Right, we would all do this, right, if it was normal algebra. But with matrices, notice how I didn't cover division. The answer is because there is none, right? We don't have matrix division, really. Okay, so we're not really allowed to do that. What we do instead is we multiply by the inverse, okay? Because then this cancels to 1, sort of, and you just get this as the answer, okay? So this idea is what will be in section 10.5. But that's it for this section. See you guys next class.